All right, so like I said, I'm going to talk about fire-adapted landscapes, where to find some data, hopefully what might be useful to you if you are a manager of an area or of your area of interest, and then tie that into some fire management opportunities. You're going to probably hear me say fire resilient, fire adapted, fire dependent. I'm not trying to confuse you. These terms are all kind of used interchangeably. They're all kind of the same. I'm going to try to stick with fire adapted landscapes because I like that the best. But if I say resilient or dependent, I mean the same thing, and I'm not trying to confuse you. So what are fire adapted landscapes? So they're basically a mosaic of ecosystems that have adapted to survive fire and even exploit fire events. Some examples that you might be used to or have heard before are the serotinous cones and jack pine stands, where the heat of the fire is necessary to open that cone up and that seed to drop down. In oak savannas, the bur oak has this kind of corky, highly fire-resistant bark, and that's like an armor to the tree. It acts like a protected so the tree can survive the frequent fires. And then for tallgrass prairies, it's kind of neat because most of the forbs and the grasses that are in the tallgrass prairies have evolved this strategy to put their growing points or their sensitive components of the plant below the soil. And it turns out that the mineral soil is an excellent insulator of heat. So that allows those plants to be able to survive the frequent fires. So why do we care about fire adapted landscapes? Prior to major European settlement, most of the lower 48 and pretty much really anywhere in North America had at least some fire adapted landscape, some fire regime. So the take home point on this slide is that map is showing the fire regimes. I know it's kind of hard to decipher, but the take home point really is that fire was the norm on the landscape and not the outlier. So what happens in these ecosystems when there's a lack of fire or fire exclusion? Well, that's a game changer. That dramatically changed the pre-European landscape. And I like to try to find these pictures here. They're hard to find, but generally when you can see the older forest pictured on the left, that's like your pre-1900 forest, and it's almost park-like. And it has these canopy dominants, and it has forbs and grasses in the understory that allow the fire to sweep through that forest. And that's what the forests are generally looking like nowadays, heavily stocked. So fire exclusion does that to these forests, and then plus, other major landscape conversions like agriculture and residential and commercial infrastructure. So today's landscape it's not even close to what it used to be. So in forested ecosystems, and when I say forested ecosystems, I'm talking about the ecosystems kind of around here, the Great Lakes states and over to the Atlantic. Fire exclusion results in this term called Messe Fication. Anybody ever heard of that term before? Okay, well, that's a process of succession where these shade-tolerant, fire-sensitive species like maple and beech and basswood outcompete sun-loving, fire-adapted species like oak and pine. And that results in this feedback effect where the environmental conditions in the forest just don't support fire any longer at all. So the forest has essentially been messified. So this term messification was coined by Dr. Greg Nowacki and Mark Abrams in a paper they put out about a decade ago now. And this is the diagram that they use in the paper. So on the far left, you can see the pre-1900 forest or the pre-settlement forest, and it's kind of like that picture I just showed, that park-like forest. And then, about 50 years of fire exclusion, the canopy starts to close, and then you can start seeing these fire intolerant or shade-tolerant mesophytic tree species that are pictured in the aqua color there start to take root. And as competition within that forest starts to get exacerbated over about a decade of fire exclusion, the forbs and the grasses in the understory that used to be able to carry that fire are just no longer there. And then, in the foreseeable future, the shade-tolerant mesophytic tree species actually end up outcompeting the aging oak and pine and sun-loving fire-adapted species. And if you try to get fire in those forests, it wouldn't work. Yeah, I've tried many times. It doesn't work. So in our native grassland ecosystem, fire exclusion results in just a bunch of problems. Pretty much the same thing, it's just a different ecosystem. But generally speaking, remnants and reconstructed prairies degrade. That results in a systemic breakdown of diversity, and mostly due to invasion by woody and weed species, exotic weed species. And that species reduction results in less ecosystem resiliency. So once the invasion has begun, the grassland community is basically doomed. So we want our grassland communities to look like the picture on the left. You know, it's rich with native grasses and forbs instead of the picture on the right, which you can tell, you know, it's not very diverse. It's basically invaded by a few exotic species, and it looks like the cedar invasion has begun as well. Okay, so that's fire-adapted ecosystems. So how do you know if you have fire-adapted ecosystems? One of the things that I like to do is I like to look to the past. So what was the landscape like prior to European settlement? And there's some free available data that could provide some clues. And for the next couple of slides, I'm going to use KVR as a case example. I tried to look into the historical landscape of KVR to determine if fire was actually a factor. So one data set I like to look at is ecological classification systems, and it's nice online because they basically have this data in a spatial format, so you can overlay your area of interest or your boundary. So pictured there is the KVR boundary in red with that little drop pin. And these subsections, they identify the major vegetation type and then the natural disturbance. So that kind of tells you a little bit about what's going on in the pre-settlement landscape. And it turns out that these subsections were called river ravine systems, and I don't know if you guys are familiar with this. I wasn't. I'm not from here, so I was trying to figure out what was going on. And I should note that these subsections also are within the ecological section, which is the driftless area, and we're all familiar with that, right? So these are subdivisions of that, and we'll go over each of those. So the smaller one, the subsection here, highlighted in blue, is the Kickapoo, Wisconsin river ravine system. And this subsection is designated on the basis of extensive sugar maple basswood dominated forest, concentrated on steep, fire-protected topography within the subsection. Fire was probably less prevalent within the maple basswood forest than in the adjacent oak savanna or prairie. So a couple of things I'm looking at here is I'm seeing the dominant vegetation type is maple basswood forest, right? Not really widely known as a fire-dependent community at all. And there's also some other keywords in here I'm looking at that suggest that topography was a protective sort of mechanism. So fire could not get into this area, right? But what's peculiar too is that it says fire was probably less prevalent in the sugar maple basswood forest than in the adjacent oak savanna and prairie communities, which are fire dependent. So to me, it looks like KVR straddles the boundary between the two. So the larger subsection to the west and to the south is called the Mississippi-Wisconsin river ravine system. And this subsection is characterized as almost all the tallgrass prairie was restricted to it. Tallgrass prairie and bur oak savanna were the major veg types on ridge tops and dry upper slopes. Oak forest was common on moisture slopes. And although the tallgrass prairies were restricted to the narrow ridge tops, they often extended continuously for 30 or more miles along major stream divides. So we're talking tallgrass prairie, bur oak savanna, oak forest, all fire-dependent ecosystems. To me, it seems peculiar why we have these fire-dependent ecosystems in such a big area, and then bam, it hits an ecological subsection where it isn't. So it's kind of like, what's going on here? So I took a look at another data set. I'm sure you're probably familiar with this map, the Wisconsin original vegetation. And I have called out here on the left the approximate KVR location. And sure enough, it does kind of look like there's a big block of sugar maple basswood forest with an oak component, and then also maybe a contingent of pine in lowland hardwood forest as well. So I was able to find that data online and then overlay the KVR boundary on top of it. And sure enough, we got a big block of sugar maple basswood forest, and this is your fire protected plant community. And what kind of struck me was when I saw this was it's basically the exact same shape as that ecological subsection. So that tells me that there's something going on here that's protecting this area from fire. But look at all the communities around it, to the north, to the west, and to the south. We have prairie, oak openings, and oak forest. Those are all fire-adapted communities. Maybe the prevailing winds hit that southwest corner and spread off, and I don't really know what's happening, but as a person that's not from here and I'm trying to figure this out, I'm kind of going, what's going on here? Because we have all these fire-adapted communities within this big block of non-fire adapted communities. So trying to put the puzzle together basically is what I'm trying to do. So zoomed in a little further on that. Sure enough, again, you can see the sugar maple basswood. Red oak, white oak is what the big green areas are classified, with a contingent of white pine and red pine. And then just some solid stands of white oak, black oak, and bur oak. Is that pretty representative of the area around here? Okay. So this data does actually work. But another data set that you can get online is, and I like to look at these too, is the public land survey maps by the Government Land Office. These are really cool maps. A lot of times these plat maps will actually show the transitions from one ecosystem to another. So what I was looking for here is these areas on these plat maps might have been delineated out as prairie or oak openings. Unfortunately, I didn't see anything on these maps that made me think you had some significant fire-adapted communities within the reserve boundary itself. Nonetheless, a good resource for looking into that, whether or not you have fire-adapted communities. Another data set that they have online, and it's pretty easy to get to, is to figure out the bearing trees or the witness trees. Anybody ever heard of those before? Okay. Well, these are the tree species that the surveyors recorded along the section lines, along the corners and then the midpoints. And I know this is kind of a mess. It's a big mass of yellow, but the next slide I zoom in a little tighter on the southern half of the reserve boundary. So the acronyms here are, SU is sugar maple. I think there's some white pine, bur oak, white oak, linden, which is basswood. LI is linden and basswood. It's the same thing. Elm, some of the hardwood species and the conifer species that the previous data sets were basically corroborating. But this is also cool too, because then you can see forest composition, pre-settlement forest composition, which is kind of nice.
So you're saying that before the Europeans got here, this area of the KVR was never really hit by fire?
I don't think so. That's not what the data is showing. It's basically showing to me that it's, and this is really part of my next slide, the data analysis that I saw from a person not familiar with this area is pointing to a pre-settlement timbered landscape and probably not historically dependent on fire as a natural disturbance. I don't want to say that that's exactly what happened because I don't know. But the available data that you can get online is showing that it probably wasn't dominated by a frequent fire regime.
The area right outside of it was.
It was. So then it begs the question, why? What characteristics around here protecting this area from fire? Just driving in, I mean, it sure seemed like topography might be one of them. But I don't really know. I'm not from here, so I was kind of thinking, well, we'll have a discussion after this PowerPoint. Because I'm curious now. I mean, this is really kind of making me go, what the hell's going on here? But nonetheless, I mean, the dramatic change in the landscape, today's landscape it's not even close to what it used to be. So, and it's probably not going to go back to the way it was, right? I mean, we're not going to have a reforestation effort that's going to take 200 plus years to get it back to the pre-settlement landscape. So, an important question that all natural resource professionals have to answer, Marcy, what do you want your future landscape to be? And are there opportunities for fire? Well, I was poking around the KVR master plan, and I saw that there were 14 goals and objectives related to land management, water, and wildlife, and a substantial amount of those goals and objectives, in fact, 71% of them, could directly benefit from fire as a management tool, and some probably already do. But there's also this other component in that KVR master plan called action items from 2010 to 2015, and there's 6 of them. And I thought 4 of them were very applicable to fire management, whether it's direct or indirect applicability. Adding 10 to 15 acres of prairie or oak savanna over the next 5 years, well, those areas are going to need to be managed by fire, for sure. They're fire-adapted ecosystems, and they need prescribed fire. Conducting forest recons and inventory of the reserve boundary, or the reserve resources rather. Well, that's an excellent opportunity to figure out what your forest stands look like, and if there's oak or oak pine or oak hickory, some of those forests are going to need fire, especially for regeneration purposes. Maintaining some areas through prescribed burns and grass management, I mean, that's a no-brainer, right? And then continue to address invasive species with mechanical and chemical control. I would argue that if you pair fire with mechanical and chemical control, you'll get more bang for your buck every time.
Does fire kill buckthorn?
No. Only chemical.
With chemical control.
With chemical
together.
control. Yeah,
Buckthorn needs like a couple punches.
does.
Can't do it just one.
In like an iterative process of chemical, fire, regeneration, chemical, fire. I mean, it's the worst of the worst. It's terrible. So I also saw this really cool land cover map that they have in the master plan. By the way, I'm sourcing the master plan here. I'm not robbing from it at all. I'm sourcing it. Yeah, I got it online, so I figured. But I thought this would be a great opportunity to identify areas for restoration and reconstruction, right? So these maps have it parsed out by percentage of occupancy on the landscape. Native grass is 3%. Old field or an open area is 14%. Wetlands are 17%. That's 34% of the KVR landscape, all definitely areas that could be utilized with fire. And yes, wetlands did burn historically, and they need fire. Despite the fact that they're wet and they have a wet underlayment, they still need fire. Another opportunity possibly would to take that old field, open area 14% and start moving it up to that native grass restoration and reconstruction and bump that thing up to 17%. That would be ideal. So 53% of the KVR landscape is wooded, right? You see you have a lot of timber out here. Well, what do those forests look like? I mean, I came in on what's the highway again? 131. It looked like a lot of your pine, your timber was down in the low areas, and then you get into hardwoods in the upper echelons of the topographic characteristics. I mean, this is driving by at 45 miles an hour or whatever. But that action item of forest recon and inventory would be critical to determine what these stands look like. And I'm not sure if this has already happened, but a lot of these stands probably could really directly or even indirectly benefit from fire, is my assumption with that.
That's what we've got Dave.
Right. So are those stands comprised of oak or oak pine, oak hickory, and some of those other fire-dependent communities, fire-dependent species rather? And I heard some other folks talking about timber harvest out here, and I know it's probably a I don't know if you do clear cutting or selective harvest or what your harvesting regime is. But there are opportunities for post-harvest restoration in these areas instead of just letting them go fallow. Fire introduced in these areas afterward is valuable.
I could have just asked that. We just did some logging,
Yep.
and everything comes back maple.
Yeah,
And
you don't
so
want
if
that.
If you were to run a fire through there, would that get rid of all those maple trees that are coming up?
Over time, yeah. I would
Helps
let,
a lot, especially in the northern area where we live, we do that quite often
yeah.
to try to bring back more pine and oak and less maple and aspen.
So that's the process right there. You get that regeneration of maple, right? Because it's occupying this void of tree species, and you get these mesophytic tree species that don't like fire. They come up in droves. If you start moving the trajectory of the ecosystem with fire, then you get the species that can adapt to that fire regime.
Our valley that we had huge pine trees. We've got one of those pine trees in the state record book.
Yeah.
And old oak trees, huge monster
Yep.
oak trees. And that's what I think it used to be, because the whole
Yeah.
trunk said they used to burn that
Yeah.
all through there.
Right. And
And
that's
so, yeah.
those would be good candidate stands to get fire back into, for sure, especially oak and oak pine contingents.
Yeah.
Yeah, definitely.
It's a lot of work. Spray it on
I made it.
trees.
Just in the nick of time. So I went through that really fast. I apologize, but I don't want to take any of your extra time up. So just some quick conclusions. Talked about fire adapted landscapes and how ecologically widespread they were in the past. Fire was the norm on the landscape. They're quickly being converted if they already haven't been converted. Today's landscape isn't even close to what it used to be. Where to find some useful data. Everything I showed you today I found online from a guy that's never been here before. So it's doable from wherever you're interested at or wherever you manage your resources. And then I tried to determine if KVR had fire adapted landscapes. Doesn't seem like that, but today's landscape might present some opportunities there. And then using some of that data to guide fire management opportunities. And those are some of the sources that I used. I didn't even talk about land fire. That's a whole nother source that I use, but didn't really have time to put it into this because Dave took up too much time. That's all I got.